Okay, as I said last lesson, we are going to look at some truth tables today. So last lesson at the end, you should have written down the truth tables if you didn't have them already. And below on this screen, you can see 4 different truth tables. One, it shows an exclusive disjunction. One shows an inclusive disjunction. One shows a negation, and one shows a conjunction. So first of all, I want you to see if you can match up which truth table goes with which statement, and then I'd like you to work out or remember what terms you would use when writing these sentences. So pause the video until you think you know the answer to both. Okay, so you should have decided that this first table here is a negation table. That's when we use the word not in the middle of the sentence. So we've got P and we've got not P in this case. If P is true, then not P must be false. If P is false, then not P must be true because they are always the opposite of each other. This second table here is an inclusive disjunction. You can tell by the little downwards V. And for the inclusive disjunction, we use the term or. And for the disjunction to be true, we either need both P and Q to be true, or just one of them. So P could be true and Q is false, but the inclusive disjunction is still true. So I could say, today is Thursday and I like mushrooms. Today is Thursday. No, it's not. Today is Wednesday. I could say today is Wednesday and I like mushrooms. Today is Wednesday, I do not like mushrooms, and therefore this is still true because it's Wednesday, not Thursday. You can also have P being false and Q being true, it's the same idea, and the inclusive disjunction is still true. If both of them are false, however, the inclusive disjunction is false. And of course in sentences you'd use or, so this is P or Q. This table here is the conjunction table. So this is our and, P and Q. The only way for a conjunction to be true is if both of the statements are true. So if P is true and Q is true, then the conjunction is true. But if just one of them is false or both of them are false, then the conjunction is false. And then we've got here our exclusive disjunction. Again, we'd use the word or, and at the end of the sentence we'd put but not both. So this is P or Q but not both. So if both of them are true, then the exclusive disjunction is false. We can't have both. If only one is true, like in these two examples here, then the exclusive disjunction can be true. But if they're both false, then the exclusive disjunction is also false. Okay, so I said to you last lesson we're going to be using these a lot more. So let's have a look at how we're going to use them. So, when you come to construct a more complicated truth table, it takes several steps, and we use these ones that we've learnt to construct the more complicated truth tables. So the first thing you need to do is analyse the statement that you're given, and this is why I was asking you to practice these statements here and what they mean. So looking at this statement, we've got not P, then we've got a conjunction and not Q. So P up here is I am studying French and Q is I am studying Chinese. So here I have the statement I am not studying French and I am not studying Chinese. So how do I go about writing a truth table to show this? Well, first of all, those little yellow markers should be on the nots. Not is the first thing I need to do, not and not. So I'm going to use a truth table for not, the negation truth table. So this is our negation truth table. If P is true, then not P must be false, and if P is false, then not P must be true. So, I know I have these options of combinations. I could have P being true and Q being true. I could have P being true and Q being false. I could have P being false and Q being true. And I could have P being false and Q being false. Those are all the combinations that I could have. If I then negate those options, oops, hopefully, there we go, then when P is true, not P is false. When Q is true, not Q is false. When P is true, not P is false, and when Q is false, not Q is true, and so on. So I've just negated each of these statements. The next thing I need to think about is the part in the middle, and. So now I'm going to use a conjunction truth table. I'm interested in this part here. I'm not interested in P and Q anymore. I'm interested in not P and not Q. So here's my conjunction truth table. So I'm going to apply this now and see what it means. So I've just taken this part, the not P and not Q part of our negation table, and if not P and not Q are false, then the conjunction between them must be false. We can see that down here. False, false, false. If not P is false and not Q is true, then the conjunction between them is still false. So here I've got false and true, still false. If not P is true, but not Q is still false, then the conjunction between them is still false. The only way for a conjunction to be true is if both statements are true. So this is the table that I end up with. Oops. There we go. So that's my answer here. You can see I could put P and Q in front here, so I'd have my P and my Q here for comparison purposes. I don't have to have them there, but sometimes it's helpful to compare. Right, your turn. See if you can write yourself a truth table for this statement. Pay close attention to the way the statement is written, because the symbol should help you decide which part to do first. I'm thinking BODMAS here in particular, the beginning of BODMAS. So pause the video and see if you can work your way through to see which truth tables you should use to help you. Okay, let's see how you got on. So first of all, we should be paying attention to these brackets. The brackets are telling us that this is the first part of the statement that you need to pay attention to. So we are going to do the P or Q. And we can see that in the sentence, I am not studying either French or Chinese. So we've got the French or Chinese at the end here together. That's the first part that we're going to pay attention to. So we're going to use our inclusive disjunction table. So here's our inclusive disjunction table. When P is true and Q is true, then the inclusive disjunction is true. And as long as one of them is true, the inclusive disjunction is still true. But when they're both false, the inclusive disjunction is false. However, I'm not interested in this. I'm not interested in P or Q. I'm interested in not P or Q. So I'm now going to need to negate. So I add an extra line on my table here. So if P is true and Q is true, then not P or Q is false. If P is true and Q is false, then not P or Q is still false. The only way for not P or Q to be true is if both of the statements are false. The negation is the direct opposite. If P or Q is true, then not P or Q must be false. Now just quickly, let's have a look. This is the table from the first question, and I've just popped that P and Q on here. Okay, then we've got our negation, not P and not Q, and then we've got our not P and not Q. And here I've got the table from our second question. We've got P and Q, P or Q, and then not P or Q. Notice they're in the same order, so P goes true, true, false, false, and Q goes true, false, true, false. The same here, true, true, false, false, true, false, true, false. And look at the answers. They're identical. The top three are false and the bottom is true. We say that these statements are logically equivalent. We use an arrow that's very similar to the if-then arrow, but it has an arrowhead pointing in both directions. So we would say that these statements are logically equivalent. We could write them out in symbol form. Not P and not Q is logically equivalent, an arrow with two arrowheads, to not P or Q. It means that they give the same answers regardless of what P and Q combination we try. So, your turn again. Ignore that bracket. The same statements, I'm studying French and I'm studying Chinese. Without the bracket there, I'd like you to work out how to draw the truth table for this. Not P or not Q. I am not studying French or I am not studying Chinese. Pause the video, write your truth table, and I'd like you to decide whether this is logically equivalent to the other two statements. Okay, so ignoring this bracket, because it shouldn't be there, we should be starting off with the negation. So, I am not studying French or I am not studying Chinese. So we start off with our negation. I'm going to bring up our negation truth table. Here it is. Anytime P is true, not P must be false, and anytime Q is true, not Q must be false, and vice versa. Now, that's the negation, so I've negated both P and Q. Now I need to include my inclusive disjunction, the or. So I'm going to use my rules for the inclusive disjunction. Again, I'm not really interested in P and Q anymore. I'm interested in not P and not Q. So if both statements are false, the inclusive disjunction must be false. Because for an inclusive disjunction to be true, at least one of the statements must be true. And that's why all the rest of these are true. Because in this case, not P is true, in this case, not Q is true, in this case, not P is true, and in this case, both of them are true. So the inclusive disjunctions are all true. Looking back at your other truth tables and comparing to the values of P and Q, you should notice that these values here are not the same. So this statement is not logically equivalent. It does not give us the same truth values for the values of P and Q that we put in.